going to look at confidence intervals for proportions. So part of the video is going to assume that you have a package of M&Ms, which is what we're going to look at. So if you don't have a package of M&Ms, you may want to purchase one if you're able to, and kind of follow along with me. I'll just make up some data for now so that we can use it when referring to different examples. And I'm not going to go through the entire activity. I'm going to skip ahead to number 13 after I fill out this table. So basically, in the study, the population of interest is going to be M&Ms. We're going to be looking at different colors and the proportion of colors that make up a bag of M&Ms. So the parameter that we're going to estimate is the proportion of each color in a bag of M&Ms. So let's say, for instance, you open up a bag of M&Ms, and inside you have the following. You've got 20 blue, 5 brown, 15 green, 18 orange, 6 red, and 14 yellow. That's a total of 78 M&Ms. What I want to do is change each of those colors to proportion. So we know to do that, you're just going to take the number of M&Ms that are blue, for instance, and divide by the total number of M&Ms. That gives us the percentage of M&Ms that are blue. So when you do 20 divided by 78, you get 0.256, which of course is 25.6%. 5 divided by 78 gives you 6.4%. $15 divided by 78 is 19.2. 18 divided by 78 is 23.1. And so on. And of course, our percentages should always add up to 100%. Now you know that your bag is your sample, and not every sample is going to be the same due to natural sampling variation. The statistic is the sample proportion, so the proportion of each color in the sample. To estimate the proportion of any of the colors, we're going to follow the following steps, okay? So let's say I'm interested in knowing what percentage of blue M&Ms there should be in any bag of M&Ms, or what percentage of orange M&Ms there should be in any bag of M&Ms. We don't know what the population parameter is. The M&M company claims that there's, X percent of blue and X percent of orange, but let's say we don't know what that is. We can use our sample proportions, which we're going to call p hat. So these are all your p hats. All of our sample proportions, our sample statistics, they will lead us to the true population parameter. So we can make some estimates, and we can be so confident. So we're going to look at different confidence levels. Let's say I want to be 95% confident. Okay, what that means is not 95% certain confidence in that way. It means like if you were to keep taking bags, random bags, over and over and over again of the same size, so 78 M&Ms in each sample, 95% of them would contain the true population parameter, so the percentage of M&Ms that are blue. If I wanted to be 80% confident, that means that if you had, let's say, 100 samples of bags of M&Ms that had 78 M&Ms in them, that around 80 out of the 100 would contain the true proportion of M&Ms that have whatever color it is you're looking for. So those values that we're going to use, those p hats, to kind of determine what the population parameter is, we call those the point estimates, okay? So we're going to look at point estimates, and then of course we're going to have a margin of error because we know every sample is different, and because of that, we have to kind of allow for some error to be within our confidence interval. So we're going to come up with an interval like a lower number and a higher number, and we're saying that somewhere in between is the true proportion of M&Ms that are blue or orange or whatever it is you're looking for. In order to figure out that margin of error, we need to know the sampling variability. So we're going to look at the standard deviation. Now, you want to keep in mind that we don't know the standard deviation of the population. So we have to instead use p hat. If you'll recall, when we were looking for standard deviations of proportions, this was the formula. But when we're dealing with confidence intervals, we don't know p. Like, I don't know the true proportion of M&Ms that should be blue or orange or whatever. So therefore, I don't know what the standard deviation is. So instead, we're going to, instead of using p and q, we're going to use like p hat and q hat, because we're going to rely on our point estimate, our p hats, to get us close to what the the standard deviation of the population is, okay? And we call that a standard error. So it's not an error as in a mistake, but it's the standard deviation based on the point estimates or sample proportions we have, instead of using the population parameter. Okay, so I'm going to lead you through the steps here, and you can apply this to the activity itself. So if you can get a bag of M&Ms, you kind of want to follow along, and after you watch the video, and see if you can complete the rest of the activity. Okay, so the M&M website states that the proportion of green M&Ms is actually 16%. So that's the wrong one. Let's go to number 13. All right, for the last estimation problem, compute an 80% confidence interval for the proportion of orange M&Ms. All right, so let's start here. So if I need to compute an 80% confidence interval, what I'm saying is if I was to take 100 bags of M&Ms, let's say, around 80 of them would contain the true population proportion. So it's going to give me the exact percentage of, in this case, orange M&Ms that the company claims there is. Okay, so to do that, I need to know the following formula for confidence intervals. So here's the generic formula. You need a point estimate plus or minus the margin of error. Okay, that's basically what a confidence interval is. So the formula is pretty easy. But let's fill in some stuff here. Like, what is the point estimate? The point estimate is going to be our p hat, our sample proportion, in this case of orange M&Ms. The margin of error is made up of something called the z critical value, so we call it z star, and then we multiply that by the standard error, okay, of p hat. So p hat here is going to be our proportion of orange M&Ms. So if we go back and look, for orange, we have 23.1. So I'm going to convert that back to a decimal, which would just divide that by 100. It would be 0.231. Okay, so my p hat for orange is 0.231. That's my point estimate. So we're saying, like, okay, in our sample, 23.1% of the M&Ms are orange, plus or minus this margin of error. So the z critical value, if you go back and look at the activity here, I kind of explain what that is somewhere in here. The z critical value is, it's right here. It represents the number of standard deviations that you're using, okay? And it's determined by the confidence interval. So if you look at 95%, the critical value is 1.96. So if you think about that, that kind of rounds to almost 2. And why is that important? Remember, the empirical rule said that 95% of the distribution will fall within 2 standard deviations of the mean. So 1.96 is a little bit more exact than 2, okay? If we're looking for 80%, our z star is 1.28. So that's how many standard deviations on either side of the mean we're looking at, Okay, so when it's time, we're going to fill in that 1.28 for our z star. Now the standard error is going to be your standard error formula, which remember is just the square root of p times q over n, except remember we don't know p and q. So we need to use p hat, which is right here. So we've got 0.231 and then times 1 minus that. And then we're going to divide by our sample size, which for me was 78 M&Ms. If you're doing your own bag of M&M activity, you're going to take whatever proportions you got and whatever sample size you got and substitute that in. Okay, so now I need to calculate this. So I want to find the margin of error here. And to do that, we're going to go to the graphing calculator or any calculator. And let's type in 1.28, which is my critical value, and then times, now I have the square root, so I have to hit second x squared, okay? And I've got 0.231 times 1 minus 0.231, so I'm going to use parentheses around that, okay? And then close it off. And I'm dividing that entire thing by 78 and then hit enter. So my margin of error is like 0.0611. Okay, so I've got 0.231 plus or minus 0.0611. Okay, that is my confidence interval. And it's expressed in plus or minus form. We're actually going to write it using parentheses. We're going to come up with like boundaries. So to do that, I need to do 0.231 minus 0.0611 and then 0.231 plus 0.0611. Okay, and that's going to give me my boundaries now. So 0.231 minus 0.0611. So that's going to be my lower bound, and then 0.231 plus my margin of error, and that gives me my upper bound. Okay, so what exactly does that mean? It just means that I am 80% confident that the true proportion of orange M&Ms is between 16.99% and 29.21%. So somewhere in there is the true percentage of orange M&Ms. Okay, and we're 80% confident. Again, meaning if we were to take many, many samples over and over and over again, approximately 80% of them will contain the true proportion of orange M&Ms. And you are able to look up what the actual percentage of orange M&Ms is. So if you do a quick little